Okay, I'm just opening. Okay, and we are going to do question. Give me a minute. I'm just opening the question.
All right, ma'am.
Uh, Finally, I'm going to tell you about the one-way Nova test, means a table. By using that, mm, we can conclude F. This is required table. I'm telling you. Maybe we have done that day. I'm just telling you. Include means in staffs, and now I'm telling you by using a table. Source of variation, sum of square, degree of freedom, mean square, and finally F. See. This is for within. And SS, sometimes they can give you in this form SS within, but most common symbol is MS or W also. Okay, means W for within we are taking. Sometimes they can give you in suffix by writing within, or most probably they use short form this. Okay, are you getting?
Yes, ma'am.
Okay, and formula for this is summation, double summation. Mean J is equal to 1 to up to K, and J is equal to 1 to up to L. X minus X bar J square, square. Or simply instead of J and this you can use straightly. Okay, means instead of these values you can straight use as this x minus x bar square. You can use as also, but sometimes they can give you like I or J here. Okay, so meaning is same, just I and J just denote the position of the value. Okay, you got the meaning of I and J where when we use this xi or xj, you know the meaning of these
Oh, ma'am, can you explain it
I
again?
and J. Pardon?
Can you explain it?
Sure, sure. I'm telling you what it means. Means simply we can write this x or xi, or what it means by xi means. So if we have values of x like 0, 1, 2, 3, 4, we have 5 values. Okay, and either we can denote the x only, or we can denote by xi. When I is equal to 1, it means first value of x, that is 0. When I is equal to 2, that means x second value of x, that is 1. So I represent just position of the value. Okay, are you getting now?
Yes, ma'am.
Yeah, similarly if we take I is equal to 3, then third value of x, that is 2. Now got it, meaning of I. And same for J also, means any like symbol in suffix denote the position.
Yes, ma'am. Got it now.
So either you can use here I, J or I, or you can use directly. Okay, without using that. By using an example, you'll understand better. And next source of variation is between, and last we find total of them. So either you can use here S as sum of square between, or simply you can use SSB also. And this is, have you done the that day also, or I'm just checking this. Maybe we have done this. I'm just checking. that day we couldn't save. Hmm. SSB we can find by using an example. You will understand it well. This is J, and here J is equal to 1 to up to K, and J is equal to 1 to up to L. And here we are using X J bar minus X bar whole square, and SST means sum of square total is equal to summation J is equal to 1 to up to N, and xj bar minus x bar whole square. And degree of freedom for within, this is k minus 1. Degree of freedom, this is minus k. We have done already also that day. And freedom total, this is mean square for within. Either you can take within suffix in, or you can write MSW also. And that is equal to SSW over degree of freedom for W means for within, and MSB mean square for between is equal to SSB over degree of freedom, and F is equal to MSB over W. This is, or what we can do instead of this F, alternatively means we need to find these all terms for this one way ANOVA testing test. Sorry. F we can find by using this formula also. MST mean square total, or MSE mean square error. Mm. Where MST you know very well, mean square total, and MSE mean square error. And SSE we can find by using this formula. or MSE. Sometimes they can say U mean square due to error or MSE mean square error. In some book or in some material they can use this also. And what is the formula to find them? MSE is equal to 1 by n summation I is equal to 1 to up to n, or maybe they'll give you j in the form of j also. J is equal to 1 to up to n, and yi minus yi cap square. What it mean? Or n number of values or data points. Data points, and y yi observed value, and yi cap predicted value, because sometimes they can give you in this form. That is why we need to know. Like if they have given to us this one and this one, then we can find f directly. Okay, or if they have given to us this data, then we'll find by using this table. Now let us do one question to understand this well. And here this f is said to be uh, f is said to be ANOVA coefficient, because they can give you two types of question. Means, or one, they can directly ask you find the ANOVA coefficient, or they can give you a data, and that you need to compare whether, as we have done that day, like mean of different group are the same, or at least one of them is different. Okay, they can give you in any way out of them. So now we are going to, do you want to ask anything?
No, ma'am.
Okay. One second. For alternatively to find only this ANOVA coefficient. Hmm. MST, MSC, and uh, MSC we can find by using this formula also, or or MSE, S sum of square SSE over N minus P. What is this? I'm going to explain you. And also MST, because sometimes they can give you a direct question to find only F by using these values. This is equal to SST over P minus 1. What are these values? Because F is, as we have done, F is equal to MST mean square total and over MSE mean square error. And we can find MST and MSE by using these formulas. Okay. And what are they? P and small n, or small p and capital N. What are they? Let us understand. And this SSE. How can we find this SSE? And SSE. I'm writing here. SSE is equal to summation n minus 1, and we need to find S. And here P total values of population, last data, and total number of samples in a population, total number of samples in population. My mistake. Mhm. My mistake. SSE is equal to summation n minus 1 into s square, and this is small n s square is, and s is equal to standard deviation. You got these all formulas, or shall I repeat you anything? See, we can find this f, that is ANOVA coefficient. Okay. We find f, you know very well that day we have done for hypothesis testing, and or we can find directly this for any given data. If they'll ask you find ANOVA coefficient, that is f, we can find by using this. If we have data, okay, we can find by using this table also, or we can find by using this alternative method, this one, okay, where mst, where mean square total, and msc mean square error, we can find mst and msc as, if we have data then we can find by using this formula, or we can use by using this also, okay, where n,
Yes, I'm gotten it. Oh,
you got, okay, and capital N is total number of observation. Now let us understand it well by using an example. We have question, shall I send you this question on WhatsApp?
yes,
Then
ma'am.
I'll do, okay, I'm just sending you, then I'll explain you the solution.
Yes, ma'am, I got it. The question.
Okay, question 1, and I'm going to explain you solution of that. Animal, number of animal, average, average domestic animal. I'm taking in short, okay? Domestic animal, I'm using this DA, and standard deviation. Standard deviation, shall I use SD for that? Standard deviation. This animal name we'll write as use as such. And number of animal, we are using n to denote this. And we are taking x for that average domestic animal, and standard deviation is denoted by small s. And we need to find MST and MSC. To find MST, we need SST. Okay, so SST is and SSE. See, uh, to find this MST and MSE, we need. So MSC we can find by using this. Okay, and MST we need it. So now let us find it. Now let us find SST first, and this is equal to summation n into x minus x bar square, and SSE, this is equal to this one, summation n minus 1 into s square. So animal name dog, cat, Mr. Dogs 5 and cats also, and Mr. also 5. So here each equal to 5. So here n is small n is 5, and we have three groups. So P is 3 because we have three types of animal. Then P is 3, and each have 5 5. Then n is equal to 5, and capital N total number of observation means all these sum of this 5 plus 5 plus 5. So this is capital N 15. Now we have here x, we have 12, 16, and 20. So here we have we need to find x bar also. Remember x bar, sum of all values divided by number of values.
X bar is the mean only, right?
Yes, exactly. So we have 16. Okay, because we need to find this. So n is 5. This. So this column, for this value n into x minus x bar. So n is 5, x is 12, minus x bar is 16. So this is rough work, okay? So n is 5 into x is 12 minus 16 and whole square. So 5 into, we have here minus 4 square, and 5 into 16, and we have 80. Okay, got it? So here we have 80. Now 16 minus 16, we have 0 here. And let us find this. 5 into 20 minus 16 whole square. So 5 into 4 square, and 5 into 16 means 80. You got it?
Yes, ma'am.
This, and this is summation n into x minus x bar square is equal to 160. This is SST. Or simply you can write it also like you are finding this column for only this one, and from here on next page we can show this summation n minus 1 into s square, or you can show here SST is equal to summation n into x minus x bar square. So this is 160. Okay, now uh, MST is equal to SST over small p minus 1. So p is 3 and SST is 160. So MST is 160, 3 minus 1. So 160 by 2 is equal to 80. This is MST, mean square total. Now we need to find SSE. SSE is summation n minus 1 into s square. So let us find this. So n minus 1 is 4 because n is 5. So n minus 1 is 4 into s square. S we have, first value is 4. This is 1 and this is 16. So s square is for this 16. 16 into 4 because n minus 1 is 4. Okay. So this is 64. Got it?
Yes, ma'am.
Yeah. And n minus 1 is 4 only, and into 1 square because s square is 1 only, so we have 4 here. And 16 square is 256 because we are taking it's a square. So 256 into 4. 256 into 4, we have 1024. Now let us find sum. 1024 plus 4 plus 64. So this is 1092. So let us find now SSE first, then we'll find uh, MSE. So SSE is Oh, my mistakes. Shit, my mistake. This is 2 and over and 4. My mistake. This is sorry. So we have first standard deviation 2 and second 1 and third is 4, 4 only. So n minus 1 is 4 into 2, sorry, into 4, because n minus 1 is 4 and as square is also 4. So this is 64. Got it? N minus 1 is 4 into as square, that is 1 only 4. And square of this 4 into 4, that is 64. Are you getting me?
Yes, ma'am.
Yeah, by mistake I have written here a square of standard deviation. Now I have taken a real value, means original value 2, 1, and 4. So we are taking here as a square. That is here we have 4 and 4 into 4 because n minus 1 is 4. So we have here 16. And as a square is 1 only because 1 square is 1 and into 4 is 4. And as a square is 16 and into n minus 1, that is also 4. So 16 into 4, we have 64. So that is uh, 84. So SSE is 84. MSE is equal to SSE over N minus small p. So SSE is 84. This capital N is 15 minus p is 3. So 84 over 12. MSE is equal to 7. Okay. So F, ANOVA coefficient, F is equal to MST over MSE. So MST is here. Okay. MST is 80 and this is 7. So now calculate it. 80 divided by 7. So we have 11.42. Okay. This is answer. Value of ANOVA coefficient. You got it?
Yes, ma'am.
I'm just opening the next question. I'm giving you a question, okay? And you can do yourself this similar question. I'm sending you. Is it okay with you?
Yes, ma'am.
You can try it with yourself.
Okay, ma'am. And ma'am, once I'm done, can you send me the solution and I'll send it to you and you can check it if it's right or not?
Pardon?
Ma'am, after I finish that question, either you send me the solution or I'll send you and you can check if it's correct or
Sure,
not.
sure. Sure, sure, sure. I'm giving you example, okay? After that, I can give you solution also. But first, just try yourself, okay? I have sent you a question.
Yes, ma'am. I've received it.
So you can just do it. And after that, next class we'll do questions related to previous method. Means we need to compare mean. Okay? We'll do that.
Okay.